Okay, so I'm going to try recording this from my Ubuntu desktop computer, and that way it's a little bit nicer. I like using my actual desktop computer as opposed to my, show it right, my little MacBook, right? This is what I normally record my videos on. But I like having a desktop just because you're able to, like, little bit bigger screen, not by much, but bigger screen. The keyboard is at the right place. It's not like this, and you're not like hunched over all the time. It's much more comfortable. Although I know that the streaming quality of the video is not as nice as the MacBook, but you know, we'll try this out. Anyways, what I am trying to do is I have my, I was, in the last video, I ran into a problem with sorting, and I had not actually done much sorting with Leetcode, so I went and I watched a video. In particular, I watched a video with quick sort, and now I'm trying to say, okay, great, let's figure out how to actually practice that. So I haven't written any algorithms for it yet, but I will be attempting it in this video. So let's sort an array. Let's try it. Okay, so it said that this one is, I asked ChatGPT which algorithm would be, I asked ChatGPT which algorithm would be used in, let's get to the right language, used in quicksort, and it told me this one, so we're going to try it. I don't know how it's actually going to work. I probably should have, anyways, I'm just practicing. This might be a complete failure. That's fine. That's fine. Okay, so given an array of integers nums, sort the array in ascending order and return it. Okay, you must solve it without using any built-in functions. Yep. Okay, so what we're going to do is just try to remember how to take the pseudocode, which I watched in the video, and actually apply it to real code. That's kind of essentially what this video is trying to do. So what we're going to do is we're going to have an array, and that's going to be equal to something like this, and we want to kind of pick a pivot. Okay, so we pick a pivot and then find its rightful place, and then put all of the smaller elements to the left, all of the bigger elements to the right. So this is going to, we have the nums array, okay, and now what I want to do is I want to have a function which will perform that operation. So we should have, this should be recursive, right? I remember it being recursive. So let's, I will need to call this on itself, right? So I'll need another function here called like solve, and then pass for now. Okay, so I want to say base case will be if length of nums is equal to 1, return. And now what are we actually trying to return here? So I need to return the index at which, wait, okay. Well, the positions of any output is just going to be the list of the array. Is it supposed to be done in place or not? Okay, I was thinking about having sort array as kind of the recursive function that I would do on itself. Okay, I'll think about this. So now what I want to do is I want to take my array, I want to find pivot, right? So is equal to, and then I guess I also say like if length of nums is equal to 0, then we also return. Okay, so now I can say pivot of nums indexed at 0. So this is our pivot point, and now I want to solve it, right? So I'll say pivot index is equal to solve, and then I want to pass in pivot and array. Pivot and array. So I'm going to come up here, I'm going to get pivot and array. I also need the starting and ending points of the array that I'm trying to actually perform this on, which would be what? And then I need to check like if it's greater or less than the actual array, or greater than the index at pivot. So num, I'll just say element is equal to array indexed at pivot. Okay. And now I want to pass in what do I want to pass in? The high and the low? Do I pass in the high and low here, or do I do it in here? So if I solve this, right, okay, fine, and then I get back the pivot location, and now I want to sort for like this, and then I say I want to sort the left hand side, so I'm going to do this recursively and say sort array sliced at from index from 0 to pivot index -1, right? And then we do the same thing, sort array, but this time it's going to be, we want the starting index to be pivot index +1 all the way to the end, okay? So we keep doing that, and then we eventually, once we come back up, then we return. And I don't think, because this is going to happen, this array is going to happen in memory, so it should be okay. Kind of like this. Well, now I need to focus on this. So what is my goal here? My goal is to move everything to the left, which is smaller, find the pivot where the pivot should be, right? That's what this is. Okay, and then return back the index. So the way that I'm thinking about doing this is I have the element. I want to find I and j. I is equal to 0. J is equal to length of array which is how many elements it is, right? But I want the index, so it should be -1 to get the last index. Yeah. So now what I can do is say okay, so the next step is something about like, what was it? I forgot. It was so the general is we are trying to move all elements smaller than pivot to the left and all elements greater than pivot to the right. Okay, how do we do this? We need to iterate through each of the, we need to iterate through until we find a non-conforming one, right? So while I is less than length of array is this a -1 or not? I don't know. And j is greater than 0, but we can include 0, okay? So that means that we can do this. Oops. Equal to, oh, but that would be -1. Okay, there we go. If this is the case, then I want to while what? No, we don't need parentheses there, I think. While I still need to do this condition here. And array of I is less than or greater than, which one? If it is less than element, if it's less than element, we just want to go to the next one. Plus equals 1, okay? And then this will stop at the non-conforming index, okay? And then we do the same thing. Well, j is greater than or equal to 0. Okay. And array indexed at j is greater than element, because that's conforming, plus equals 1, okay? Now what I can do is I check if not I greater than or equal to j. So if I is greater than j, then I don't want this to happen. Okay? Okay, so now that means I want to swap them, right? So temp is going to be equal to array at I. Then I'll say array at I is equal to array at j, and then I'll say, oops, I'll say array at j is equal to temp. Okay, kind of like this. So let me come back and think about this logic here. So if they're crossed, I don't want to do it, right? So if I here is greater than j, I don't want to do it. So let me actually just simplify this logic. So if I is greater than j here, yeah, so it's okay. And then once this exits, we return okay. Oh, we can't return yet, actually. But I will have to do pivot index, right? That's a local variable, which should be good. Awesome. So now they've either crossed. Should I go and I've sorted, I put all of the elements in order. Not in order, but just like all of the smaller than the pivot. So I need to take the pivot and put it in the middle, right? And where is that going to point? I think I need to do another swap of the first element in the array to the last element of like the sub array, which is where this I is. So I think, where is I going to finish though? That's another thing that I'm always tripped up about, like where is I going to finish? So I will try saying, I don't even know. Temp is going to be equal to the first element, so array indexed at 0, and then I'm going to say, well, that's going to be element, I guess, but whatever. Array indexed at 0 is going to be equal to array indexed at, and here we go, this one is either going to be I, okay, or I minus 1, I'm not sure which one yet. Okay, and now I say array at I is going to be equal to this temp there. And then for the pivot index, I would return I. So now, is this like an in-place operation, or do we need to do like return nums? I don't know. Let's press this button and see if it even runs. Might have problems with some syntax. Solve is not declared. Okay, that's awesome. So let's see, I need self here, and then I need to say self.solve. Where'd you go? Okay. So it's unhappy with this. Name array. Why are we... Okay. Nums. Okay. Array of pivot. It's upset about this. So maybe if we have a empty, but we should have checked that here, right? So there always should be a 0th element. equal to 0, if the length is equal to 0 or 1, we return. So we'll never get to this point without here. So what about pivot? Oh, wait, hold on. I'm gonna do pivot myself. I don't need this pivot. Here, element is going to be array of 0. Like that. Oh, and this actually probably should... Do I need to move them over by 1? Here? I'm not sure, and I'm not signed in to ChatGPT to even ask that. Hold on, am I able to do... I can do pause recording, sign in, and then do start recording again? I don't know if that's possible. I'll try it. Hopefully it doesn't erase everything. Alright, so we should be back up and running. I have Gemini here. And close out of this. We are here. So I will copy this, paste it into Gemini, and see where we messed up. Alright. Using the horse partition scheme, or a variation of it. Your intuition to use 2 pointers. Okay, however, your code currently has a few logic gaps. So let's try to understand where my logic gaps are. Why your current solve is failing. The J pointer logic inside your second inner while loop. If you have I plus 1 instead of J minus 1, this means J never moves. Oh, did I? Oh, well, okay, that's... Actually, this should be minus. J minus equals 1. Let's just run it to see if it works. I doubt that was actually the problem. Because right here on this while loop, I'm never moving it. Yeah. So the pivot swap, you're using array of 0 as the pivot after the pointers meet. You swap with I. If I has moved past the current spot, your pivot might end up in the wrong place. In Python, creates a copy of it instead of the original. Okay. You need to pass in low and high indices into your function to sort the array in place. Why are we doing cyclic sort? Oh, it's because up here it was asking about, I asked about cyclic sort up here. Now I am to solve this question here. Okay. Do you still think I need to use that cyclic sort? No, you should not use for this specific problem. Okay. But why? Cyclic sort only works when the numbers are a continuous range. I see. Okay, here the numbers can be and have any gaps. Okay, so cyclic sort is only if they are continuous. Okay. Why quicksort is tricky here? Well, quicksort often... okay. Leetcode's test case usually include killer arrays already sorted or all identical numbers specifically designed to make standard quicksort fail. Okay, merge sort is guaranteed here. Okay, well, I'm not learning merge sort right now, so I don't care. If my thing is technically correct, but Leetcode purposefully introduces wrong or terrible, what do you call it, killer arrays, like, that's not my problem. And I'm not saying that, like, oh, I don't, well, I don't care about it. That is true, I don't care about it, because I'm trying to learn the concepts, not solve the problem, if that makes sense. Yeah, okay. Alright, so... quicksort. Alright, so this is the way that they did it. They have a helper function in here, okay? And quicksort of from 0 to, okay, so let's start with that kind of updated. So we're going to take all of this and just reset. I'm going to submit it as my like attempt, okay, and then I'll reset it. And then we'll try it on the other ones. Okay. There we go. Description. And now I come here. I want an inside function. So def, and then quick sort. And then the parameters, I want to perform quick sort, right? So quicksort from 0 to length of nums. Now I don't know if that's -1 or not, but anyways, whatever. Return nums, and it should not be a copy this time because we're doing a helper function in here. Okay, so now I need to pass in start and stop. Okay, it's going to be these two, and now stop is, I want it to be inclusive, right? So this should be -1, I think. Okay. So now what I want to do in here is, I have my 2 pointers. I want to quicksort is going to be recursive, so I'm going to call quicksort myself, right? And it should be fairly similar to the one that I did. No, they're having quicksort within, so you're doing all of this, you don't have a helper function, okay? And it is -1, okay, I got that intuition right. Randomize pivot to avoid squared on sorted arrays. So I can just do this because why not? Whatever. So base case is going to be, Alright, so let's just do that, whatever. So now think about the base case. If start is greater than or equal to stop, that means I only have one element in here, return. Okay. Otherwise, I need to perform the sort. So then I come in here, I get the index, I randomize it, okay. And now I want to say, what actually do I want to say?我真的不知道。What do I want to say? What am I even doing right now? So I have my index, and now I want to find, so element is equal to nums indexed at pivot index. Okay. Now I want to keep going. Now I want my I and j. I is going to be equal to. So essentially this is a helper function right here, but I'm just replacing that entire code that was up, and I'm just putting it down here before I do the sorting, right? 'Cause then I'm going to have two lines down here, sort left and right. So then I'm going to do quick sort, and then I'm going to say so starting is going to be start, and ending is going to be pivot index -1, and then quick sort, and then pivot index +1. Okay. Like that. But I need to modify each sub-arrays to be so now I want to come in here and say I is equal to start, j is equal to stop, and both of these are inclusive. Okay, so I want to say, I want to keep changing. So while I is less than stop, I guess it would also be equal to stop. Oh, hold up, no. This one, and j is greater than or equal to 0. Okay. Then what do I want to do? I want to find non-conforming. So I do while, and I have to check this exact same thing here. Okay. And nums of I is greater than, is less than, because that means conforming. Okay. Element I plus equals 1. The other one is the same thing. Come on. Well, j is greater than or equal to start, and nums of j is greater than element, then we j minus equals 1. Alright? And now I want to keep going. Say if I and j have been I is greater than or equal to j, then I don't want to swap. So if not this, come here and then perform the swap. Temp is equal to nums at I. Okay, now nums at I is going to be equal to nums at j, and then I want to say nums at j is going to be equal to temp, like this, and then we still need to plus equals it, or plus, or move our pointers, is that correct? And they do this plus 1, so this was wrong. This is wrong in my, I'm wrong, but I don't know why I'm wrong. And this is, by the way, this is something that I arrays and indexing is literally my least favorite thing about Leetcode. Like, that is, I keep talking about trying to face head on those things that I'm scared of, and definitely indexing and those off by 1 errors. I always get this wrong, and it's so hard to just visualize because obviously, well, like when you close your eyes, you can't see anything. You can't visualize anything. So I need to be able to like write it down. Apparently, some people can. Like, I was hearing about this. Like, you close your eyes and you can visualize an apple or something like that. I was like, that didn't make any sense. But apparently, some people can like visualize or like legitimately see things when they close their eyes and imagine it. I was like, that doesn't make any sense. It's like a superpower or something. Okay, so 2-pointer partition. So then we come in here. Yeah, I think we're doing, well, that's not a else if. I did it. Put the pivot in its final location. Okay, let's copy and paste this. I'm just gonna submit it, that way or actually let me run it. It's not going to pass, but I want to see it, make sure that I don't have any syntax errors, and I'll fix the syntax errors and then submit it. That way I have a record of what I did. Left is not defined. Oh, right. There we go. Just make sure that we get the syntax errors out. Okay, come on. Come on. Okay. Good. So now we can submit it, and I can copy this, put it into Gemini. What did I do wrong here? And what are the concepts you see me struggling with? Okay. The moving pivot. You pick a pivot index and store it in element, but your while loop starts swapping elements all over the array. The issue, the actual pivot element might get swapped to a different index during the while loop. When you finish the partition, the pivot no longer is at pivot index, so okay. Swap the pivot at the very beginning of the range before you start, so you know exactly where it is, okay? Bound issues. So it doesn't like this, is very risky. The issue, if I or J go out of the bound, start or stop, you might comparing numbers that were already sorted. The logic breaks because you're inferring subproblems you've already solved. Or interfering, yeah. In your last line here, you forgot the second element, stop. Okay, that's fine, that's whatever. The concepts you're struggling with, based on the code, I see you walking, okay. The partition contract. In quicksort, the goal of partition isn't just move numbers around, it's find the final resting place of the pivot. Concept. Once a partition is done, the pivot should be at index k. Everything to the left is smaller, everything to the right is larger. The pivot never moves again, okay? You are currently treating the pivot index as a static boundary, but the partition process is dynamic. Inclusive versus exclusive trap. Yeah, that's true. You're using here the concept when working with subarrays, you must strictly stay within the start and stop. Using 0 as a lower bound in a recursive call will make the code look at the entire array over and over again. Okay. Pointer overlap logic. You use if here the concept in the horse partition. The point where I and J cross the split point, knowing exactly where they land is vital. Yeah, so I actually agree with the three concepts in here. The partition contract, the index boundaries, and the pointer overlap logic. So these three things are definitely things that it's nice to have names to it. So the next follow-up question is, I agree with you about the three items you listed as gaps in my knowledge. How can I best go about studying and practicing these concepts? Think creatively. Okay. So, yeah. Need to write these down as well, because I think that that's good. So swap pivot to start strategy is the easiest to keep track of the elements. Okay. If you find frustrating. I highly recommend merge sort. And we're not learning merge sort right now. Merge sort handles sorting. Okay. Think creative. Okay, let's do this. Okay. To master these low-level algorithmic concepts, you have to move away from looking at code and start looking at memory. Most students struggle because they try to visualize the logic in their head, but the human brain is bad at tracking multiple changing variables, like all of, yeah. Here is a creative multimodal plan to bridge those gaps. The desk checking method, kinesthetic practices. Instead of typing, grab a physical deck of cards, post-it notes with numbers on them. The exercise: lay out 8 cards, okay? Pick one as the pivot and physically move them. Move your left index finger as pointer I and your right as J. So the goal is to perform the swap only when your fingers stop. You can't do it with your hands without cheating. Or if you can't do it with your hand, come on, let's read. If you can't do it with your hands without cheating, looking at the whole array, you don't understand the pointer contract. Okay, pointer contract. Constraint study. Try doing it with the killer array and see why nums of low pivot versus nums of low. Okay, so the difference between the equal sign matter for keeping the halves balanced. Okay. Build a trace. Visual logic. This is how NASA engineers used to verify code before compilers were powerful. Create a table on paper with columns I, J, nums of J, and the array state. Okay. Step. Swap. Okay. Step 1 is... Oh, okay, so it's just like a kind of what I do with comments. Okay. By filling this out manually for a small array of 5, you will identify the exact moment your off by 1 error occurs. You'll see the I fly off the thread, or fly off the end of the array, realizing, oh, I need a boundary check there. So study loop invariance. This sounds academic, but it's a superpower. A loop invariant is a statement that is true at the start of every iteration. So for partitioning, everything to the left of I is less than or equal to pivot. The practice: every time you write a while loop, write a comment above it stating what is guaranteed to be true. If your code breaks that guarantee even for 1 second, your logic is flawed. So, reduced constraint problems. Instead of jumping straight to O of n log n sorting, solve these component problems on Leetcode or HackerRank. First, they isolate the specific concepts you're wrestling with. Okay, so now it's giving me... okay, I really like this, because what this is saying is there... So, let me give a little bit of a story. So, in the past, I was really... When I was in university, I was really... Actually, community college, when I was at Portland Community College, I was really struggling with calculus. Specifically, it was integral calculus. And one of the best pieces of advice was this, like, old... It was from the Soviet Union. There was about maybe 60 or 70 at the time, so he grew up, like, during the Soviet Union time. He was very, like... I don't know how to describe that kind of character, but he was extremely nice, and what he told me was, when I told him that I was having difficulty, he said, Tim, no, you're not having a problem with calculus. No. You are having a problem with something very specific. Okay. You need to go in, and he said, you need to go in, find the specific problem that you are having, and kill it. This was his exact thing, right? With the very, like, stern, strict, like, Russian strong character. I really don't know how to describe that character. But just go in, find that problem, and kill it. And that really stuck with me. Like, I unfortunately, I lost contact with him, but I really wish that I could go in and just, like, let him know, like, hey, by the way, that piece of advice was so helpful. Like, thank you so much for this. And what I did was, I said, okay, great. I don't have a problem with calculus. I have some issue. I'm not understanding it. Let me try to constrict what am I not understanding. And it actually led me to basic mathematics. I think I had to go down all the way, and it was like, oh, well, do I understand something in... So I'm in integral calculus. I go down to derivative calculus, because it was okay, well, here's the question. I don't understand how to do this question. Well, this question has, okay, well, now I need to do derivatives, right? Okay, well, do I fully understand the derivative part? Well, no. Okay, well, then I go down, what don't I understand about this derivative part? Well, do I understand every single element within the equation? Well, no. What's going on with the, like, how did they do this one operation? Oh, and then going down, well, that's an algebra question. Okay, well, now I need to go down and do I not understand the algebra, right? And it was kind of a humbling experience, because I was watching these videos which were like for not basic math, but, you know, algebra. And I just felt like, man, I shouldn't be watching this. I should already know it. But I had to, like, humble myself and say, no, well, apparently this is a gap in my knowledge. And then I was able to understand that concept, and then almost, since we're doing Leetcode, recursively go back up and build back up to, oh, now I can do this problem, because I understood all of those sub-problems. And where I'm seeing this right here is, okay, so if I'm able to do so I actually want to find those algebra problems, the ones that are able to help me not do the sorting. Okay, maybe I'm not ready for the sorting, but go down and say, what concepts, what's the name of the concepts, maybe, where'd it go? These three, what's the name of the concepts, and then what are some practice problems that I can do to understand those algebra questions, those sub-problems that I'm not understanding. So I'm happy about having this to be able to identify, hey, this is some problems that you can try to improve yourself. So I really like this. Okay, so let's keep reading. So move zeros, perfect for practicing two-pointer swap without the complexity of recursion. Okay, sort colors, Dutch national flag. This is the final boss of partitioning. It uses 3 pointers instead of 2. If you can solve this, quick sort partitioning will feel easy. Okay. Binary search. This is the best way to master index boundaries. So, okay, binary search. I always like to do it with like a tree, right? Although I have not done binary search in a long time. And that kind of goes back to what I keep talking about with being scared of. I really am scared of arrays. I don't like arrays. I always get the off by 1 error, and I really do not like it. I can do recursion, I can do backtracking, I can, well, I'm not good at it, but it's just, I really do not like arrays, and so it's something I need to face head on. I need to say, I'm going to do arrays, I'm going to learn and practice and practice and practice. I got to the point where I could do binary search, but that was like 6 or 7 months ago, and then I haven't touched it again because I either in my head I'm like, oh, okay, I can already do it, or I'm my subconscious is scared of it or something. I don't really know. But use the rubber duck with a twist. Explain your code line by line to a duck or a YouTube channel. Okay, but do not say the variable names. So increment I until it hits a big number. I am moving the left. Okay, so this is how I should frame it. This is how I should say it. I need to take a cup of breath, and whenever you talk for, actually I kind of like this because now on my, when I'm recording on my Mac, I can't see any kind of timing of how long I've been doing the video, but here I am able to see this, so I can see that I've been doing it for an hour. So like whenever you talk for over an hour, like you get kind of out of breath. Okay, so let me take a couple breaths and take a sip of coffee, and we'll get back into it. Yeah, that engineer who gave me that really good advice about math, he also helped me prepare when I was going to go visit Russia. So I went and I visited St. Petersburg, and it was, he like gave me so many good advice. He told me, don't smile in the subway, because you know, Americans, we're like this, we're right, like it, you always smile, but he told me, no, don't do this, because first off, they're going to think either there's something wrong with them, right? Did they spill something? Is their hair funny? Is something wrong with them? Well, no. And so if you're smiling and there's nothing wrong with me, then there must be something wrong with you, right? Like you have some kind of problem. And so he told me, don't go and just like randomly smile. And then when I got there, I was like, oh my goodness, that was actually very accurate, because they're not angry. It's just kind of this feeling right here. It's a very relaxed, neutral. It's a very neutral feeling. And they would look at you just like I would look at this cup. I have no emotional feeling towards it. It's just a cup. Here it is. I look at a person, and if a person asks you a question, you just answer the question, right? It's very... I kind of like it. It was very comfortable. And when I came back to America, I remember people were kind of thinking that I was rude because someone asked me a question and I said, no. I answered the question, right? It was just, they asked me a question. No. I didn't explain myself. I didn't say, well, you see, it was just, here's the question, here is the answer. And I didn't even think about it, because I was like, oh, I answered their question. But anyways, it took me a little bit of time to get acclimated back into the American mindset. So, where was I? The rubber duck. Okay. Explain your code line by line to a duck or a friend or a YouTube channel. So don't say increment I until it hits a big number. Instead say, I am moving the left side boundary, searcher, until it finds an element that belongs on the right side of the pivot. Why? This forces you to understand the role of the variable rather than the syntax, okay? So next step, try to solve sort colors, which is that difficult one that it said. The final boss. Okay. It is a partition-only problem. It doesn't require recursion. Which means you can focus 100% on pointer overlap logic. So this is another keyword that I need to focus on, and in-place swapping. I am actually going to, I have a list here. I'm going to write down these things. So I'm going to come up to here. And what's wrong with the code? So the partition contract. Okay. It's kind of interesting because we started off the day when I was trying to just do a hacker rank problem. I got stuck on a cyclic sort, and I wrote down 4 things. I did a very similar thing with Gemini. I said, oh, I don't understand this problem, and then it gave me some of the keywords, and then I went to go look at those, and then I got on to quicksort, and so I did this quicksort here, right? And then now we're going even deeper. So it's bing, 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 and now I'm just gaining a lot of new keywords which I had not heard of today. So it's really it's nice. Okay, the partition contract now. Here, okay. Index boundaries. Index boundaries. And then this one is the inclusive versus exclusive trap. Okay. Okay. Pointer overlap logic. Okay. And now there's a strategy. I'm going to write down the strategy, which is called swap pivot to start. Okay. So now we have these different methods. So, okay. Right now I'm looking for the keywords of concepts that I should be investigating. It has the specific problems, which is great. Okay. Variable names. Pointer overlap logic, which we already wrote down. In place swapping. In place swapping. In place swapping. Okay. Is there anything else that I need to extract from this? So I have that. Okay. Alright. I think what I'm going to do is I'm going to go and study more. I have my... I've been trying to extract as much index boundaries. I'm just looking. Okay, index boundaries, we have that. Trying to extract as much concepts that I'm finding that I'm missing in myself, and then from that I'll be able to go and investigate it one by one, try to get a better understanding of it. So I think that's what I'm going to do, is moving forward, I'm going to end the video, and then I'm going to go and try to study each of these, maybe go and look at these questions here and practice, and also look at more sorting algorithms. And I think what I might do is, moving forward in the near future, when I'm doing Leetcode or HackerRank questions, I try to focus on arrays, because that is what I am most scared of. That is what I am scared of, so I should face it head on. And by facing it head on, I think I will improve and become better and more comfortable with it. So that's kind of my strategy for right now. If you want to join me on this journey, subscribe. I would love to have you along for the ride. And yeah, so thank you for watching. My name is Timothy Lee Grant, and I'll see you guys very soon. Alright, let's see how it turned out.